In this video, I am going to explain about Millman'S theorem. Statement for Millman'S theorem. When a number of voltage sources V1, V2 up to Vn are in parallel having internal resistances R1, R2, Rn respectively, the arrangement can be replaced by a single equivalent voltage source V in series with an equivalent series resistance R. This can be seen by means of a diagram. These are your equivalent voltage sources V1, V2 up to Vn having internal resistances R1, R2, Rn. This V1 Rn is connected in parallel with the V2 R2. This can be replaced by an equivalent voltage source V with a series resistance R, and this load can be connected together. Then, what are the steps for solution of a network utilizing Millman'S theorem? Any number of parallel voltage sources can be replaced to equivalent one. First, you have to obtain the conductance. What do you mean by conductance? Conductance means reciprocal of resistance. So, you have R1, R2 up to Rn values. You have to find the reciprocal, that is 1 by R1 will give you G1, 1 by R2 will give you G2 and so on of each voltage source V1, V2, and you have to find the G, the equivalent conductance removing the load. Then you have to apply Millman'S theorem to find V. Equivalent voltage source is given by equation V is equal to V1 G1 plus V2 G2 plus up to Vn Gn divided by G1 plus G2 plus up to Gn. Then you have to determine the equivalent series resistance with the equivalent voltage source. That is R is equal to 1 by G. Then current through load is given by IL is equal to voltage divided by resistance. Resistance are of 2, that is this resistance, equivalent series resistance R and load resistance RL. First question. Using Millman'S theorem, find the current through RL in the circuit shown and find the voltage drop. So, Millman'S theorem states that number of voltage sources with the internal resistance can be replaced by an equivalent voltage source with a resistance and a load in series. So, equation for Millman'S theorem is plus or minus V1 G1 plus or minus V2 G2 plus up to plus or minus Vn Gn divided by G1 plus G2 plus up to Gn. So, here first you have to determine the voltage V. For that, you have to apply this equation and you have to find out the value of V. So, here you know that first case V is minus because here it is negative sign. So, negative 4 into G1 means reciprocal of resistance. So, you can take it as 1 by 4. So, minus 4 into 1 by 4. Then again second case here also voltage source is negative. So, you have to take minus 2. Minus 2 into G2 is 1 by 4. Then third case it is touching positive side. So, you can take it directly 10 into 1 by 4. So, you can take it as 10 into 1 by 4. All divided by G1 means 1 by R1. That is 1 by R1 is 1 by 4. G2 1 by R2 1 by 4. G3 also 1 by 4. So, here 4 and 4 cancel. 2 and 4 1 by 2. Here 5 by 2. So, you will be getting it as minus 1 by 2 plus 5 by 2 divided by 3 divided by 4. On solving this, you will be getting voltage as 4 by 3 volt. Next, you have to determine the equivalent resistance R. Equivalent resistance R is equal to 1 divided by 1 by 4 plus 1 by 4 plus 1 by 4, which is equal to 1 divided by 3 by 4, which is equal to 4 by 3 ohm. Now you can redraw this circuit with a voltage source and equivalent resistance connected with the load RL. Here this is the equivalent circuit. Here I have replaced this circuit with a voltage source V with an equivalent resistance R and with connected with this load RL. Now you can find out current through RL. I through RL is equal to, that is IL is equal to V divided by R plus RL. So V is 4 by 3, which is divided by 4 by 3 plus 10. So you will be getting it as I as 0.117 amps. So first we have determined voltage, then we have determined resistance R. Equivalent series resistance with the equivalent voltage source V can be determined. First R is equal to 1 by G. Then current through IL is given by IL is equal to V divided by R plus RL. Second question. Find Millman's theorem for the left of the terminus X5. Here there is a voltage source and there is a current source. First you have to convert this current source with a voltage source. So current source in parallel with a resistance can be converted into a voltage source with a series resistance. Resistance is same, that is 2 ohm. Your voltage source is R into I, that is V is equal to I into R, which is also equal to 2 into 1 equal to 2 volt. So replace this circuit with the 2 voltage sources and 2 resistances first. So here is your equivalent circuit, that is this 4 ohm 6 volt as such. Then this 1 ampere 2 ohm can be converted with a voltage source with a series resistance. So by using Millman's theorem, equivalent voltage V is equal to V1 G1 plus V2 G2 divided by G1 plus G2. Here it is touching positive side, so you can directly take it as plus 6 and plus 2. So you can take V as 6 into 1 by 4 plus 2 into 1 by 2 divided by 1 by 4 plus 1 by 2. On solving this, you will be getting V as 10 by 3 volt. Taking LCM and by solving this, you will be getting equivalent voltage V as 10 by 3 volt. Then R is equal to 1 by G, that is equal to 1 divided by 1 by 4 plus 1 by 2. So you will be getting R as 4 by 3 ohm. So you got V and you got R. So you redrawn this as in this manner, that is a voltage source 10 by 3 volt in series with a resistance 4 by 3 ohm. Since load is absent, you can easily draw this circuit like this. This circuit can be replaced with an equivalent voltage source with a series resistance. Hope you have understood this video. Please like my video, subscribe my channel and share it with your friends. Thank you.